let's get into our quiz before we start today. So we've got some answers in the chat to what is the output when you call next 3 times on this generator. A, 1, B, 2, C, runtime error, and D, stop iteration. Thus far, it seems like we have consensus that it is D, stop iteration. Granted, it is from some of the resident experts like Diane Chen and Robert Edajamzadeh, so it's possible that that might be accurate. But the point of this, going through Mike Driscoll's Python code quizzes, is to learn a little funny stuff about the Python space. So if you're new to Python, it's important to understand that a lot of the data types that you work with are what are called iterable, which is to say there's a whole bunch of stuff, usually delimited by commas, stuffed in there. And usually when you iterate, you want one at a time. And so we have this thing called a generator, or according to Mike Driscoll, a genitator. He probably could have had a potato joke in there or something. But we can tell that this is a generator here by that keyword yield that you see in the numbers function there. Yield 1, yield 2. Now that's not the greatest code, but this is really just demonstrating what an iterator, or rather a generator, is all about, which is to say it's a function that returns an iterator, if I'm not mistaken. Now we enter into the main space and define x as a function numbers. I'm not certain about that syntax, but it does actually work. More importantly, we then utilize another reserved method, or another reserved keyword, the method next, which is something that works with iterators. And so we look at the function that we've got defined there, that generator rather, and it's giving us yield 1, yield 2. But we are saying next x, next x, next x. So 3 times going through an iterator that has only generated 3 places. And so basically, let's look at the code. And I'll switch over to a REPL. All right, does everyone see that?
Yeah.
All right, so, well, let's run it. Oh, hey, look at that. Wow, what happened to the spacing there? That's crazy. All right, stop iteration. Very good. So I probably don't use enough iterators in my code. Could anyone talk about some practical applications that they use generator functions?
So the deal with generator functions is memory efficiency, right? You don't want to, so for example, if you were to create, let's say you wanted to have a list with, uh, or a sequence of say 10 million items, right? If you were to just generate a list of 10 million items, say through list interpolation, that's taken up a huge amount of memory, right? Whereas with a generator, you only use this tiny little bit of memory because it just keeps computing the next value every time you call it.
That makes sense. So instead of spitting out everything in that set, it's just the next one. So cool.
Yep.
Yeah, they did some pretty neat stuff with Python. I feel like I've just barely scratched the surface with the things I've done with it. So any of the like Python 101 level people, if this were a function, what keyword would we see instead of yield?
Return.
Yeah, just won the NVIDIA hackathon guy. You're not Python 101,
Okay.
but he's right. It would say return. All right, very good. We learned something, I think.
Yeah, that's where you say, put your hand down.
You know, trading CPU time for storage space, DM says. Exactly. All right, so some Python lulls before we get going. Oh, it's so easy. Oh no, it's actually a lot going on under the hood. All right, it's February 6th, 2025, our second installment of the Sacramento Python user group, aka SacPy. This year, welcome everyone. The topic today is running a local LLM. It's a recent new thing called DeepSeek R1 that made waves in the news, utilizing a thing called Ollama. So if you are up to it, I recommend coding along today. This one's actually fairly succinct, and you should be able to talk to at least one of the smaller models of DeepSeek, or if you are so intrepid, dig around in Ollama and download some of the other LLMs. So last month, a friend of mine, Christian Nuss, presented talking about running an LLM in AWS Lambda, and he was talking about the savings. John asks, do we need 1 terabyte free space? You know, you could do up to, I believe the largest model is 600-ish gigabytes, but the smallest one is about a gigabyte. I won't make any promises as to performance. However, you can, in fact, run a very small one on your laptop. Anyway, he talked a little bit about running an LLM using a serverless architecture that AWS offers called Lambda, and talked about basically operating the thing for like dollars a month. So this month, I figured we'd go even lower level and work on running it on your own machine. So a little background on large language models. Obviously, I think at this point we can assume that everyone's heard at least of ChatGPT. And if you're paying attention to the scene, you know there is much more than that. And they have been disrupting, maybe not in the most productive ways at all times, all manner of industries. And it's interesting to see what people are doing with it in terms of being extra productive, as well as all of a sudden taking a total nosedive in the quality of the work they're turning out because they're just, blindly using it. So we're going to go all the way back to 2006. A technology was released called CUDA. And CUDA is a much more human-friendly layer for the NVIDIA GPU line and allows for acceleration for ML. A few years after that, a toolkit was open sourced, spaced out of Google, open sourced in November of 2015. It's a machine learning toolkit by the name of TensorFlow. And adding more layers of usability for humans, this guy named Francois Chollet is the author of a number of books, one being Deep Learning with Python, published this tool set called Keras that acts as an API layer for TensorFlow, which was later acquired and made the default TensorFlow API in 2017. Now, a little later that year, a paper also came out of Google in combination with a handful of other researchers called Tensor to Tensor. And it was defined the transformer architecture that is the basis for basically any LLM that you're using today. And, I mentioned ChatGPT. I think they're some of the ones that most famously productized it earliest, but there's basically been a Cambrian explosion of these things. It's not just ChatGPT out there. It's a whole constellation of things. So fast forward to February 2023, Meta open sourced a model called Llama with 7, 13, 33, and 65 billion parameter models. They use trillions of tokens of training on these things. It was a trillion for the smallest one, and I think 1.4 trillion tokens for the biggest one. And they did it on an absolutely massive compute system and then made it available to the public. So when that came out, it was actually still somewhat onerous to install it on your own system. And a group out of Palo Alto, Ollama, founded in 2023, came out with a decent way to basically run LLMs locally. And so we're going to be using that a little later tonight to get this going. And almost up to present date, just a few weeks ago, a company out of China that was actually a quant, like hedge fund, they open sourced their own LLM by the name of DeepSeek R1. They had had some others in the marketplace too, but this one famously claims to have only required $5.6 million in training. Now, I think that's maybe a little bit of a statistical juke. I think they were not necessarily accounting for all-in costs of all of the rest of the firm's operation leading up until then, the acquisition of the talent that was able to make this possible. But all the same, the market reacted, and in a single day, NVIDIA lost 15% of its market cap, which was $600 billion in valuation. Now, that was the 20th that it was open source, and I think that drop happened just 4 days later. And one of the breakthroughs with DeepSeek R1 was that they were working around CUDA. They were working much closer to the metal than anyone was doing, at least in an open source fashion, utilizing a thing called parallel thread execution, which if you're familiar with low-level languages, there's one called assembly that works directly with chips. This is effectively assembly for multiprocessing. So they did away with, the human readable level and just went straight towards maximizing the use of the actual metal itself. And this is purportedly their performance metrics. You see them in the blue, and you see some other popular ones, ChatGPT, that gold one. As you see, it is outperformed in every single category. So moving on to the topic of the day, how to actually install this thing. So first off, Ollama. Is anyone coding along and want to help me gauge your progress as we go along? This is a pretty straightforward one. If you head to the Ollama download, you should see an option that hopefully fits you, unless you're not working on Mac OS, Linux, or Windows. Anybody coding along?
What was that again?
Is anybody like installing as we go? I can go a little bit slower and we can talk a little bit about it.
Let's see here. It's uh pretty straightforward. So here is how I did it. I'll go ahead and copy.
All right, well, moving along. Very cool. Robert's got the CLI option. Curl, very cool. Now, once you've got that installed, you can find the, oh, do I have the right one here? Oh, I see. Sorry, let me copy that over for you. Basically, when you get onto Ollama, you are given a search interface that allows you to find a number of LLMs that are available. If you look up DeepSeek, you should be presented with an interface that allows you to choose from the absolute smallest, that's the 1.1 gigabyte, all the way up to the largest. I think John was asking if we needed a terabyte. It might be fairly close once you've installed Ollama, but yeah, that largest one is quite a bit larger than all of the rest, it coming in at 404 gigabytes. Once you've got it installed, it's pretty straightforward. In the command line, Ollama run DeepSeek R1 : and then the model that you've chosen. So tonight I've got 1.5 or 1.5 loaded up. We can also run some of the other ones. I have up to 14 installed. No, I have 32B as well. 32B is definitely to the point where my machine is absolutely chugging.
It seems like it's got the same approach as like Docker, right? So you just say what you want to run, and if you don't have it on your computer, it goes and gets it.
Yep. Yeah, it's pretty clever. Yeah, so that is both your install step as well as how you run it when you actually run the thing. So uh, after my slides here, I'll jump into the CLI and then we'll play around with it and show you, well, at least on a CPU that is still not the most daunting thing to have available. But something I also wanted to point out, getting more into the history, or rather the present of where we're at with these LLMs. So previously with these large companies, Meta and OpenAI and Google and Anthropic and whatnot, their their news is all about, oh, we've put millions and billions of dollars into the development of these things. And so DeepSeek said, we did it for $5.6 million. Now, this is a paper that came out 3 days ago or was pre-published 3 days ago. This comes out of Fei Ling's lab at Stanford. They basically did the same thing that DeepSeek did and dropped it even further. I don't know if I can reconcile it, but apparently the claim is they effectively used $50 in training. So billions to millions to tens of dollars. So suffice it to say, this is not financial advice, but this might result in some movements in the market, possibly for NVIDIA again. So I don't know. Maybe there's something someone could do in there. All right. So I said this one was going to be brief. So let's move over, or let's move back to the command line and check this thing out. So I'm going to switch over now. Oh, clear you. There we go. All right. So like I said, that Ollama run and then the model name, that is both your install and how you run the thing. So here we go. We're going. So, hi, my name is Woody. Now, the DeepSeek thing has these tags that it's thinking. Now, this is 1.5. So the way that they present DeepSeek is you've got fast and dumb, and then the gradient all the way up to slow and smart. And so this is the fastest and dumbest one. So Deanna and I were playing around with this last weekend. We found some funny results. If you give it a simple task that, something like ChatGPT would handle pretty reasonably, like, please write a Python script to do the hello world, basic single line print hello world, that sort of thing. But what you'll find with this is you get a whole bunch of introspection. So here we go. Okay, so I need to create a Python script that says hello world and then run it. Where should I start? I remember from school that Python. So not exactly sure where they're getting this language here, but it's certainly fluent and absolutely ripping on output. Now, I don't know that we can see that we've actually gotten something yet. We are paragraphs in. Okay, one, two. No, they've identified print. That's great. I'm not sure about input. Ooh, hello world. Yeah. Oh, that's pretty close. We almost did it. And finally, we get to print hello world. So,
So is there a way to say don't show your thinking?
let's try that. Don't show your thinking. Write a for loop to print out 10 numbers in five. It seems
Evidently doesn't understand don't show your thinking.
it seems fairly apathetic to it. Now, if anyone's been following along and has installed it and happens to have a NVIDIA GPU on board, I'd be curious to see how this performs on your side. Now, I'm running this off the CPU, and my understanding is that they use what's called a mixture of experts approach,
Yeah.
which is, I think, multi-headed, which probably runs a little bit better on a GPU than a CPU, I'd imagine. I'm not
Probably
certain.
does. Um, but I would say that the real trick is to use it in something like uh, uh, um, Jupyter, right? Or you could use it through IPython. Um, but if you have Jupyter installed, then you just fire it up, and if you have, um, I'll show. Yeah. So you just have this. You just import Ollama, and then you can do things like this. Print Ollama list models.
So DNS, when DeepSeek talks about not using a GPU, they're talking about training and not us running the model locally. I believe they use GPUs. Maybe they weren't the really up-to-date H100s or something like that. But no, this is more about running it locally on the
Yeah.
GPU.
Yeah. So what's called inference time. Inference time is where you've already trained your model, and you're just using the model, right? Um, and so a GPU is going to make a big difference for both because it's it's a set of neural networks, and each of those neural networks, each of the cells in the neural networks requires a GPU uh, to get the answer quickly, right? Um, so so probably from what you have, the easiest thing to do is just to go ahead and fire up. So Ollama should all already be running in the background, right? And you can probably yeah. So you've got a bunch of different containers, right? Just like in Docker. Um, and okay, so now you're firing up
Eight.
R1 8. Yeah, you see, it even has an ID for the container, just like in Docker.
Yep.
Uh, so right now you're in Ollama. You're at the Ollama prompt, and so if you exit that, then you can fire up IPython, import Ollama, and do things from that.
Ah, very cool. Um, do you have a Jupyter notebook you could boot up and try that?
Yeah, I already have it running.
Okay, cool. Well, let's let this gen finish and then I will pass the share off to you.
Okay.
Out of curiosity, what kind of GPU are you running?
So I've got a um, 3090. So it's got like 10,000 CUDA cores and 24 gigs of VRAM. Um, and so what I did was I bought it used. So that knocked about $1,000 off the price.
Nice.
It's in here, in here. Yeah, in here there's nothing relevant.
So yeah, it doesn't seem to regard the don't introspect problem. I wonder if that changes with the GPU. Look at it go.
Um, let's see here. If I ask Perplexity, um, how can I turn off thinking messages in DeepSeek in Python? Okay, actually, there's the Perplexity had some canned solutions for that.
Cool. All right, I'm gonna stop the share and hand it off to you.
Okay. I can't really see what other people see on the screen, but you should see a Jupyter notebook, maybe a little with a font a little bit small on it, right?
Yep, port
Yep.
888.
Yeah. So I'm gonna zoom in a bit, and I'm gonna close that guy. Right. So yeah, so I copied it into the Zoom chat. That's how you install it from the command line. You just run import Ollama to get it um, into your program. Um, and to pull a model, if you know the exact name of the model, you can use Ollama pull command. Um, and let's see here. If I go ahead and let's say I want to go ahead and pull Llama 2. Gotta run this part first. Okay, now I've imported Ollama, and now I'm going to pull and then list. That's not going to take too long. And it's not showing me any progress. Um, so if I go back here, okay. So if I come back to this, still not done. Okay, so I'm going to interrupt the kernel. Then I'm going to re-import it. And how do I get this to use? Okay, so I think I should already have the fee model installed. And if I just go ahead and run that, yes, so that works, right? Um, so here I'm using the streaming approach. So I tell it the name of my model. I'm using the fee, which is a small little model. Um, uh, and this is my command, right? That goes under content. So I want to write a string n times in JavaScript, and then in Python, and then in Java. And so this is the JavaScript solution. Here's the Python solution, and here's the Java solution. So this is coming from the fee model. Now, if I run this in the DeepSeek model with the same prompt, so once again, it's kind of chatty, and it shows me the think, and then it proceeds to show me solutions in JavaScript and Python and Java. Um, And here I was trying something else. I was trying to have it do it in fast HTML. But we'll just stick with these for right now. And now I'm going to try Perplexity's solution for turning off thinking. So I'm going to use, let's see here, use an empty chain of thought. So this is just going to do a regex substitution for the think portion. Okay. I don't think that's really the solution we're looking for because we still had a bunch of extraneous output even outside of the think tags. Um, so for now, I'm just gonna ignore the additional output and I'll think about how to get rid of that later. Um, so what's something else interesting we could do with this? Um, so here we're streaming it. And let's set it up so that what we want to do is we want to have this just be a function, and we just want to pass a string to that function, and then it'll do all of this, right? Um, it'll call Ollama chat with streaming. It'll pass up the model and the structure of the messages. It'll just know how to do that, right? So if we call this, here we go. I'm going to make something below that. And so I'm going to say this is def uh, uh, call DeepSeek. And we're going to call this prompt. And yeah, that's right. Okay.
Indentation, Robert.
Yeah, got to indent it. Okay. And that's good. Right. And we do call DeepSeek that. Right. So this is more convenient, right? We just have a function and the mechanics of setting this up is already done for us. And it's all done streaming that. Okay. And now what's something else we want to call DeepSeek to do?
Ask it to make a generator.
Write a generator function in both JavaScript and Python. And then it's going to tell me its life story. And finally, okay, here's a JavaScript generator function that creates array by yielding elements. And you could probably paste this into Node.js to test that. And here's a Python generator. Okay, so we could we could pass it an iterable. For x an iterable, yield x. Yeah, that's a good way to do it. So in Woody's example, he kind of hard coded it to do 1 and then 2 and then nothing more after that. But here you initialize it with any iterable. So a string, or not a string, but a list, tuple, set, those would all work. And so here we pass it a list of 1, 2, 3, and then it prints it out. All right. So let's take that. And we're going to copy it. And now we're just going to take that and put it right back into Jupyter. And does it work? It does. So I passed it the array 1, 2, 3, and it yielded them one after another. And there we go. So that's pretty useful. So if you didn't remember how to generate a generator, DeepSeek remembered that. So what's something else useful we could do with this?
You could put it into an extension in your your IDE and have it as a chat window on the side. That would take a little longer.
So to generate a skeleton for a Jupyter extension, right? Let's see it. Let's see if we can figure it out. Write a the simplest possible function. I'm going to zoom in a bit. And everyone can read the writing, right?
Yep, yep. Looking good.
So it's thinking, okay, I need to write a Jupyter Notebook extension. What's the best way to do that? What kind of functionality would be useful? Blah, 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 blah. I'm going to import something Chinese at the top level. Use apply to handle any input cell. Okay. And okay, so clearly this is something that isn't going to work for me. Not sure what it was. Is it a joke? Does JK mean just kidding? Apply for the file, import this thingy. So for handle a cell, do that. Will automatically Python M Jupyter extension example. So I'm pretty sure that's not going to work. Okay. Right. Let's see. This is my Python 12. Write an example of multiplying two vectors using NumPy.
Yeah, I have not been able to find out what that library might be. I did the same DN. I could not find it on PyPy.
What?
DN mentioned that you can't find JK assorted kanji on PyPy.
Well, the import is for importing the file, but it wouldn't be the name of the package, right? They give
Uh,
you the name of the packages. Um, so yeah, I mean, you could grep for it and see like if it shows up somewhere. But most probably it was hallucinating. Okay, so I create two arrays. I take their dot product, and then alternately it does it could, oh. So these are going to give two different answers. One is element-wise multiplication, the other one is the dot product. But that looks like it's correct code. Okay. And everything that isn't supposed to be printed looks like it's commented out. So, and because it's Jupyter, we can just paste that into the next cell. Okay, so this is, it looks that's for like a JavaScript string, those three backticks. Um, okay. So that should all be valid. Yep. Right. So we're using the NumPy library, which in this Conda environment is already part of the Conda environment, right? So I just got to import it. And then I create these two arrays, and then I take the dot product. So anyone who's taken physics should know about the dot product. If not, the idea is you got two lines and they're at an angle, and you want to find the magnitude. You want to get a scalar value from those two vectors, and there you go. Um, Element-wise multiplication, I forget exactly what that is, but instead of getting a scalar value, now you get a vector. You get is what you get back. So 8 and 15, let's see here. If you do 2 times 2 times 4, okay, so 2
Yeah,
times
it's
4 and 3 times 5, yeah, it would give you that output.
right. So we got to do in physics. Nice.
Um, so what's something else we could do? We could have it create. So when it needs to make separate files, let's say we want to create a sample Flask application that's going to generate. Um, so it's gonna create HTML with some CSS and um, uh, and have it return that, right? Um, but let's see here. I can't really do that inside of Jupyter. I kind of have to do that separately. But let's see here. Write a okay. Call DeepSeek. And write a simple Flask application with uh, 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 with an example of get, put, post, and delete HTTP methods. All right. First, I'll start off by setting up the basic structure. The get method, I'll do that. For post, I'll do that. For put, I'll do that. For delete, I'll do that. Should mention that Flask runs on localhost. Testing each method separately will show each HTTP endpoint. Okay. And so it knows about this syntax here from Flask import, and then it puts each thing on a separate line. That's smart. It creates an app. It knows how to create a route. And so for this, it's just going to return a plain string rather than HTML. For post, it returns JSON. Good. You can use it like that. Explanation. Great. So it probably knows how to write basic programs in, most languages, JavaScript, Java, C++, that sort of thing. SQL.
Very
See
cool.
it too.
So there you have it, folks. Like, this is not necessarily cutting edge stuff, but I think there's a lot to be said for being able to run these things on your local device. And I think it stands to reason that these are only going to get better. And of course, so will the hardware as we move along. And we got a few more, in the chat. Ben says yes.
I'm going to stop showing for now.
Sure. Ben, if you want to jump on and show your work, you said you asked DeepSeek R1, the small model, to write a Python function.
Yeah, let me try.
All right. Kip is throwing the real stuff at us. How many positive divisors does 5 to the 12 minus 2 to the 12 have?
I don't know. Can you see that now?
Yep.
Yeah, I can see.
Purple rebel.
Yeah.
So you're just running Ollama from the command line, right?
Yeah, this is just, yeah, exactly. But it's been going, I think, for 10 minutes and like just kind of in circles trying to, do
Yeah.
some pretty complicated math for something which should be pretty simple, right? And I'm surprised by it too, because I mean, this Fibonacci example is pretty common for, anyone looking at Python. I mean, it's on the front page of the, python.org website.
Yeah.
So
Yeah. So when they say that DeepSeek just completely upsets the industry, they don't take into account that at least DeepSeek will take forever to do a simple problem sometimes, right?
yeah,
Well, if you use the DeepSeek chat webpage, you're using a much superior model to this one. This is the smallest model they offer.
yeah, true. That is a good point. So maybe it is something about that, but yeah, I'm surprised that it's just as verbose as it is, I guess.
Yeah, but I think verbosity has to do with the programming of it. I don't think it's being more verbose because it's dumber, because it's underpowered. I think it's because of the criteria that it's tuned to, right?
Yeah. Anyway, maybe I'll stop sharing. I'll let you know if it ever comes up with an answer.
Right. So yeah, one thing I was gonna say is there's like there's three different ways you can access DeepSeek, right? So the way that Congress is considering making a crime is to use the app or the web page, right?
Right. Because it's phoning home.
Because that means all of the user data goes to China, and that's a different country with your sensitive data instead of an American company, which maybe you trust more with your sensitive data. And The second way is through an API, and DeepSeek actually does have an API, and that way you can use it programmatically. And of course, the way we just did was to download the model and run it locally. In my case, I'm running it locally on an NVIDIA GPU. But because DeepSeek published all the research on this, Hugging Face has already made a clone of it. And presumably both OpenAI and Meta are busy reverse engineering the improvements in DeepSeek.
DN does not have the same national restrictions that we do, being in a wholly separate continent, and he's got the web up and is willing to show us what the state of the art of DeepSeek looks like. Thanks
Okay.
for familiar interface.
Can you see it?
Yep, looking good.
Okay, so I just copied what Ben had typed into our chat, and there's your Python straight away, and then all of the text is further down, and it's even given us a second choice, a second algorithm, and that happens. That happened, just as quickly as you would expect any response from say the ChatGPT conversation chat. All right, so we're not comparing apples with apples here.
Yeah. And it also doesn't show its thinking process, right? I guess
no,
it
just that
it shows it as an
explanation.
explanation, but it doesn't show all the chattiness of think and tells you its entire life history.
Yeah, I can't see that that's much of an advantage, except if you are wanting to see how the thing's working. GPT. See if I can do this without logging on. Okay, so that's ChatGPT's website, and this is coming back at comparative speed.
Right.
And okay, once again, giving us two code choices, two algorithms, or maybe three. Okay, there we go. With less explanation. Yeah, so if we go back to DeepSeek, we've got a bit of an explanation of how the how the different algorithms go about their business. Sorry, Robert, I missed your question.
But in ChatGPT, you have that on the O3 mini model?
Good question. No, I mean, I didn't even log in, so I assume it's the really basic one. How do I work out which model it is?
I think free is the 4.0.
Oh, I just got an answer. It just finished. It's completely wrong.
Yeah, so the local version of DeepSeek R1 it's kind of like podcast mode. Very, very sparse information density. So, hopefully the takeaway here is there's nothing to be scared of yet, but also it is possible to get these things running on your own machine. And so if you have sufficient hardware and, the models will keep coming out. I think that's a guarantee at this point, but pretty fun stuff. Did anyone else have one that they wanted to show us? All right. Well, I think that should about do it for tonight. So thanks for following along. I hope some of you were able to get that. I'll have the link up and have some reproduction steps in the YouTube. But thanks everyone, and we will see you again March 6th, I believe. Should be a good one. I believe FireDex is going to be back with their latest. So that should be a good one.
All right.
All right.
Cheers.
Cheers.
Robert,
Yeah.
Robert, would you mind publishing where we can find that Jupyter notebook you were using, please?
Sure. I'm not sure if I already uploaded it to my GitHub, but yeah, sure.
Well, we've changed it this afternoon, so just to make it awkward.
Yeah, okay. I'll just put it. I'll put it on my GitHub.
Awesome.
Appreciate that. Yeah,
But and then I'll just share that in the SacPy section of Brazen.
Perfect. Awesome. All right.
splendid.
Thanks,
Yep.
everyone.
Thank you.
See you
All right.
next month.